Hello and welcome. In this video, I'm going to explain how QoS or quality of service works on OcNOS devices. And then I'm going to show you some samples of configuration so that you can apply those in your network. First of all, you should know that we have spoken about some of the things in previous videos, such as policing and also classification. These two are applied on ingress interfaces. So what I mean by that is, in case you want to police the traffic that comes from one of the customers to you, for example, or rather, it doesn't matter where it is. When the traffic comes to here, you can just police the traffic on this interface and say that, for example, some of the traffic is going to be sent and excess traffic over a certain bandwidth limit is going to be dropped. The other thing that you can do here is going to be classification. With classification, you can say, for example, what kind of traffic is coming in, and based on the markings that we have here, we can just understand what kind of traffic we are going to deal with. Later, we are going to apply some policies on this kind of traffic. So that is what we have here. On the egress interface, for example, in case the traffic is going to pass rather to and goes towards the other side, we can do some other things. As a matter of fact, what we are going to have here is, let's say we can just mark the traffic, or we can maybe shape the traffic or allocate some amount of bandwidth to that specific kind of a traffic. And these are different things that we can do for this kind of on egress interfaces when the traffic is leaving. So for this, like I said, if you want to do some markings, what you're going to do is to first of all understand the traffic using some class maps. The class maps that you are going to use for ingress traffic is going to be of type QoS, but the class map that you are applying for egress interfaces is going to be a little different. It's going to be of type queuing. So these two are different. On queuing, what you are going to do is to say, okay, this kind of a traffic is marked with that. I'm going to allocate it to this specific queue. We have 8 queues on each interface and 4 queues on each sub-interface. Let's say that I'm just talking about interfaces. So we have 8 queues that starts from queue 0, 1, 2, 3, 4, 5, 6, and finally we are going to have queue number 7. So intrinsically, these queues have some priority. So queue number 7 is going to be the highest in priority. Queue number 0 is going to be the lowest in priority. So if you do not really want to do anything, just allocating the traffic to queue number 7 is going to say this traffic is the highest priority traffic and is going to be treated better than the other traffics that are allocated to other queues in here. What if I want to, do some things to the queues? It is possible. As a matter of fact, what I can do is I can say, okay, on this queue number 7, I'm going to do some shaping. I can do shaping under the queue. I can do shaping under the interface directly, but normally you do not really shape the traffic on the interface unless you know that, for example, on this interface you have a specific customer connected. Maybe this is one of the scenarios that you might really want to go with shaping on the interface level. But if you want to do shaping on the queue level, that's totally possible. Also, you can just set different priorities to the traffic. You can allocate some kind of bandwidth in here. So all of them could be done under queue. How are you going to configure these queues? The queues are going to be of type queuing, under class map of type queuing. And then you're going to use those under a policy map that is of type queuing again. So let's do this on router 2. Currently I have Ethernet 1 here on router 2 as the ingress and Ethernet 2 as egress interface. So let me just see what we have on each one and show run interface each one actually. So this is a switch port interface I'm going to add something to this. So let's say that I'm going to go to here, and later I'm going to add a service policy to this. But let's just start by classifying the traffic. So I'm going to say class map, and you can see that we have two types of class maps. One of them is going to be QoS, one of them is going to be QIN. QIN is for egress, QoS is for ingress. So I'm going to say type is going to be QoS. And we have match all and match any. So in case you want to have multiple criteria and you want to have all of them met, then you go with match all. That is kind of an ending between different conditions that you have. Match any means that you want to have multiple criteria and you want to say, okay, doesn't matter whichever of these are going to match. If one of them hits, then I'm going to classify the traffic in this class map. That's okay. So let's say that I'm going to say that just a name. Match all is going to be the default. So I'm going to say the type is FTP. And under that, I can just use any different types of matching. So I'm going to say match. You can say match protocol, match IP address, match different things that are possible here. So in here, for example, I can say match IP, and after that, not IP, of course, match, let's say different types. We have a lot of options. Traffic type could be L2 or VLAN, for example, could be selected. I can have MPLS experimental bits here, and also I can have layer 4 matches, for example, TCP, and after that I can say, for example, the destination port is, let's say, 21, and then hit enter. This is matching FTP. I can go with them, or I can use an access list and then put it under here. So any of them is going to work here. So let's say that I just selected FTP based on this. That is one way to work with them. So that is the FTP class. I can create different classes, but there is one class that is always there by default. It is called class default. So if I just commit this part of configuration for now, and then say do show class map, you can see that we have a class default here for QIN, and also class default for QoS. Let's just go down. That class default, which one? This one for QoS, for example, and this one for QIN that has a Q in the end. This class default is going to match any traffic which you have not matched them before. So if you have class maps defined, but some other traffic are going to be there without matching to any of those class maps, then this is going to that traffic is going to fall into class default. So anyway, I just created this FTP class map here. So what I'm going to do is to use a policy map. So I'm going to say exit. Policy map is let's say of different types again, and here I'm going to go with QoS, and then the name is going to be, let's say, police. And under that, I'm going to say, okay, for different classes, I'm going to treat them differently. So if I just say class type, the only type which is going to appear here is QoS, because the policy map is of type QoS. So you don't have to really go with class type something, but the class that I just defined was FTP. So just type class FTP, and under this class FTP, you can just do different things. For example, you can police that traffic, you can set priority for that, or you can set different queue for that, different things that you can do here. Let's say, for example, I'm just policing this. So I just say police, and after that, CIR is going to be selected. You can say color aware. For example, different types of, different colors are going to be treated differently. And you can say color blind. Here, let's say, for example, CIR, which is the most common one, and then based on the percentage of the bandwidth, you can just police the traffic, or you can do different things. This is one thing that we have done them before. You can set different things here. For example, COS value, that is rewriting the markings, whatever markings has been there before, you are rewriting that. So let's say that customer sends you some traffic and it says that, okay, this is of utmost priority for me, so I have set this to COS 7 maybe, and then you say, okay, COS 7 is not the utmost priority for me, yours, maybe, mine, no, I want to set it to DSCP, so to COS 6. So you rewrite it to 6. Or for example, you have received COS, which is a 3-bit value, because this is a trunk link, and then you're going to rewrite it to send it on the other interface that you have, for example, using a DSCP value or IP precedence value or whatever that you want to have. Or you want to put it in a queue. Like I said, queues are based on the interface. We have 4 queues for sub-interfaces, 8 queues for the interfaces. Queue number 7 is going to be the highest priority queue, actually. And if you do not do anything, there are some profiles that are going to do that for you. And that profile says that, for example, COS value 7 is going to be mapped to queue number 7. COS number 0 is going to be mapped to queue number 0, based on what we have there. If you just say set queue, then you can just say, okay, I'm just putting this in queue number 7, and then hit enter. So if I just say commit, that's going to be accepted for me. And for now, if I just say do show run policy map, and show run policy map, actually, not do show run. And show run policy, it doesn't show here. So it doesn't matter. We can just say start or begin by policy. I hit enter. It says that here is the policy map that we have created so far. There is only one class in this, but normally you have lots of classes inside the policy map that you have configured there. So final step is going to be setting this under the interface. So if I just say interface ETH1, then I'm going to say service policy, and the service policy, of course, is of type QoS. And if I just say type, that's going to say QoS, and for QoS, the only thing that we have is input, and then the name was police. That's it. And then I can commit this configuration here. And later, whatever I do is going to just show up in policy. So if I say do show policy map for interface ETH1, it's going to say, okay, we have this policy map that is matching FTP. What it's going to do is to set it to queue number 7. You don't really do FTP on queue number 7 because that is the highest priority, and FTP is going to be one of the low priority traffics, because if you have some drops in FTP, that's going to be okay, and FTP is going to retransmit that for you. That's a TCP traffic, right? Normally what you're going to put there in highest priority queues are going to be sensitive traffic, such as voice and video. But anyway, this is just for the sake of demonstration, so you do not really be so fussy about that. So you can see that it says, okay, under Q0, we have not configured any type of shaping, we have not configured any type of limiting. On queue number 7, we have not done anything on these queues. But anyway, let's say that now we are going to do something about exiting traffic. So the first thing that I want to do is to match the type of traffic that we have here. The class map for FTP that I have created is of type QoS. That's not going to work here. So what I need to do is to create a class map. And let's just exit the interface. I'm going to say class map, and this time type is going to be queuing. And the name is going to be FTP underline queue. So under this, again, the same thing. We can just match. If I just go with match, then I can use interface. I can use queue. Based on the queue, I can just receive it. I can see service template. I can do different things here. So let's say that I'm going to say match queue, and the queue number 7 is going to be selected because we have just set it to 7 previously. So, and after that, what am I going to do to this kind of a traffic? What I'm going to do is to say, exit. Let me commit this part. What I'm going to say is I'm going to create a policy map which is of type queuing, and the name is going to be police underline queue, or not police, as a matter of fact, let's say shape underline queue. And then I'm going to say, okay, for class FTP underline queue, what am I going to do? I'm going to say I can shape it to a percentage of the bandwidth or some bandwidth here. My interfaces are 100 megabits per second, so let's say that I'm going to shape it to something like 50 megabits per second, and then hit enter. Or I could do something else. I can just say, okay, I'm just going to give it a priority. So the priority could be of level, and after that, for example, priority number 7 is going to be there. It says 0 to 7 for ports and 0 to 3 for services. So for now, I'm going to say priority level is going to be 7. And then hit enter. What else can I do? I can do two different things here, which one of them is random detect. One of them is weighted fair queue, as a matter of fact. So I can just select one of them. So let's just commit to configuration so far. That's going to be okay. And it says that because you are using this, cannot configure more than 4 priority levels. It says that you cannot really go beyond 0, 3 on non-default queues. So that is going to be, you know, negated for me. So let's say that I'm going to say no priority level 7, then committed. Then I'm going to say priority level is going to be something like 3. Okay, and now committed, and this time I should not really receive any error. So what I was going to speak about, let me just remember, okay, so I was going to speak about these two. We have random detect, which means that whenever the depth of the queue is a little beyond the threshold, then we are going to just drop some of the packets randomly. So if I say random detect here, then it's going to tell me, okay, so what kind of a traffic color you are going to drop. Let's say that, for example, red traffic is going to be dropped for us. Or I'm going to say, okay, some minimal threshold is going to be configured here. And for that, I'm going to go with, I don't know, 10 and 10 kilobits, 10 megabytes, kilobytes, bytes, or based on the millisecond, of course, you can configure, or based on the number of packets. And also microseconds, which translate to US in here. I'm going to say 10 megabytes, and then that's going to have a maximum threshold, which means that beyond that, everything is going to be dropped. Between 10 and, let's say the maximum threshold is going to be 12 megabytes. Okay, and this means that before 10, I'm not going to drop anything. If the traffic goes beyond 10 but less than 12, then I'm going to randomly drop some of the traffic. If it goes beyond 12 megabytes, then I'm going to drop all of it. So that's it. And I can just go with drop probability as well, and say that, for example, the default value is 80%. That's okay. Whatever percentage that you want to say. I'm going to say 75%. And then hit enter. That is what I have configured here, and I'm committing. Here what it says that is kind of an error is, let me just bring it here. It says that I have just configured the queue size more than maximum configurable size. So these are some hardware limitations that you need to know before doing any of these stuff. So I'm going to say no random detect right now. Oh my god. No random detect. So you need to be very careful about the limitations of the device that you are working with. Based on that, you can just configure this. The other one, weighted fair queuing. It's going to select the weight, and based on that, it's going to give it a weight. Let's say, for example, I'm going to say 40. And then hit enter, and then I'm going to commit this configuration. So weighted fair queuing is going to be set for this kind of traffic. For FTP, of course, you should go with a lower weight, but that's okay. The higher weight is preferable over lower weight. So that is how you configure. So let me just show you running configuration of policy map. Right here it says show policy map is going to be better. Policy map, of course. Here you can see that I have this different policy maps that I can show you here. Shape queue, and then we have configured this FTP to shape to 50 megabits per second, and also we have just set it to weighted fair queuing, weight 40. So we can just use this under the interface. So if I just go to interface ETH2, I can say service policy of type queuing. This time it's going to be output only, and then I'm going to say the name is shape queue and hit enter, and then commit this configuration. Okay, let's say that you do not really want to do any of these stuff, and you want to just go with the configuration, the default configuration that we have. And based on that, like I said, we have some queues. The highest priority queue is going to be queue number 7, which is the 8th queue in our queue length, if you want to have under the interface, and queue number 3 if you have sub interfaces. And then what is going to happen? COS values are going to be mapped to these queues. And how are they going to be done? If you say do show QoS profile, you can see that there are some profiles that are configured for us by default, and I believe that QoS profile has a dash in between. So you see that these are different QoS profiles. For example, this one, profile default, and the profile type is COS to queue, which means that it is mapping COS values to each one of the queues. And the mappings, you can see that there is nothing under this right now, but you can go with some details. The other profile is queue colors to COS, DSCP to queues, and each one of these profiles could be, so let's see, QoS profile, and after that I can just select a name for that. Let's say, for example, QoS profile default, and hit enter. This is the mappings that you see here. It says that for input, this is 0 to 0 and 7 to 0. Everything is going to be mapped to 0. But for output, that's going to be different. So you see that normally they are going to be assigned some colors, but you can just change them actually and give them some different colors. And detailed mapping, go down here. And I need to say terminal width, and there's going to be a lot of information here. So I really say terminal width is going to be 256, and then go with this command that's going to give me a higher amount of information in here. You just check this. You can see, for example, DSCP values are going to be mapped to colors here. And if I just go down, for example, this one queue color to DSCP, based on that, if you have, for example, queue number 7, it's going to be matched to DSCP 56. And let's say this one is DSCP to DSCP. If I receive a traffic with DSCP 21, I'm going to map it to 21. This means that I'm not going to change this unless there is a very good reason. So you can just create your own QoS profile. In case you want to, all you need to do is to go to here and say QoS profile, and then let's say, for example, this one, DSCP to Q, let's say, and then give it a name, or you can just go with the default one and change the default. You should not change the default. You should just create something new. Let's say that this one is my mappings, and then hit enter. And under this, you are going to do this. You are going to say, because this is DSCP to Q, then I'm going to say DSCP, let's say for example 48. Then I need to say, okay, it goes to queue number 5, for example. And then I can assign a color, or I can assign another DSCP variable. Let's say that that's okay. And then I can do lots of different mappings. For example, DSCP from 1 to 56. I can just set all of them here and give them my own value. And after that, then I can use this QoS profile in other places, and instead of just using the default one. So that is an overview of quality of service in OcNOS. And you can just go with the default, or you can configure everything based on what you have and use it. But for now, I guess this is going to be okay. And one thing that I just forgot to show you is queue limit, which you can just configure based on bytes, and then some milliseconds maybe. So let me just exit here. I'm going to say policy map, and that type of policy map is going to be of type queuing. So type, let's say queuing, and ABC is the name, for example, for that. Let's say that I'm going to say class FTP underline queue, and then under this, what you're going to have is to set a queue limit, which is this one, queue limit. And then you can say, for example, what is the minimum threshold for that? Let's say, for example, this, and after that, you can say kilobit per second, megabit per second, or whatever, or kilobytes actually, not kilobits. So let's say that I'm going to say with 1000 kilobytes per second, and then hit enter. You can just go with some values for milliseconds as well. So that is how you just configure queue limit in this case. So that was an overview, and I hope this has been informative for you, and see you in next videos.